Each box in the Pokemon storage system is an electric field. These fields lie side by side as pictured below. When Bill was first making the system, he only had 3 boxes. He was able to include more by figuring out the total change in electric potential from the middle slot in box 1 to the middle slot in box 3, thereby optimizing the system's operation. Assume that the boxes were equidistant. What was the total change in electric potential? The change in electric potential is found by taking the dot product of the electric field and the displacement vector delta L. Here we can see that we have 3 distinct electric fields, 500, 0, 0, 200, 400, 0, and 300, negative 100, 0, and we are given the positions of 2 slots in the box system at negative 300 meters and 900 meters. To find the potential difference, we first have to break up our electric fields into chunks we can work with. We know the positions of the slots, and since it's one-dimensional, we can find that the midpoint is 6 meters between negative 3 and 9, as these 2 points are 12 meters apart. So, since negative 3 plus 6 is 3 and 9 minus 6 is 3, our midpoint is at 300 right in the middle slot of box 2. Finding a second midpoint between each box allows us to find the electric potential later, so dividing 6 meters in half gives us 3. Negative 3 plus 3 is 0, so the point between boxes 1 and 2 is at 0, 0, 0, and the point between boxes 2 and 3 is 600. Using basic math, we can find that the displacement between each box is 3, 6, and 3 meters as shown here. We do this because when we move from one electric field to another, we have to know the specific distance between those fields. Now we can move on to calculating the electric potential given by the equation delta V equals the negative sum of the electric fields, dotted with their respective displacements. For the first potential difference, we dot the first electric field by the displacement between the middle slot in box 1 and the barrier between boxes 1 and 2. So here, we have negative 500 volts per meter, dotted with 300 meters, which yields negative 1500 volts. We do the same thing with the second electric field, and so we have negative 200, 400, 0, dotted with 600, yielding negative 1200 volts. And then the same thing with the final electric field. We have negative 300, negative 100, 0, dotted with 300, giving us negative 900 volts. Finally, we add those potential differences together to find that the total change in electric potential is negative 3600 volts.